Hello everyone, welcome to rkphysicsshiksha. In this video, we are going to discuss a in a question from Kinematics, where we will be calculating the displacement. So we are provided with the particle's position along the x-axis, and it is depending on time, as x is equal to 2t square minus t cube, and x is in meters and time t is in seconds. They're asking us to calculate what the maximum positive displacement of the particle is along the x-axis, and at what instant does it attain it. These are the two things that we're supposed to calculate in the question provided. So for that, we are provided with the displacement, which is x is equal to 2t square minus t cube. Now if you differentiate it with respect to time, differentiating with respect to time, we get the velocity, which is v is equal to dx by dt. That will be d by dt of 2t square minus t cubed. Further, on simplifying it, we'll get 4t minus 3t square. This is the velocity of the particle, which is depending on the time t. Now, let us also calculate what is the velocity, or what is the time at which the velocity of the particle is 0. That can also be calculated just by actually equating v is equal to 0 in the given equation. That is another simple question you will get. And for now, what we are asked here is to calculate the maximum displacement. So for minimum or maximum displacement, for minimum or for minimum and maximum displacement, for minimum and maximum displacement, dx divided by dt should be equal to 0. Dx by dt should be equal to 0, which is the one which we already calculated there above, which is 4t minus 3t square should be equal to 0. That is t into 4 minus 3t is equal to 0, from which we can say t is equal to 0 and t is equal to 4 minus 3t is equal to 0, we can say, and from which we get t is equal to 4 by 3 seconds. Two values you have. See, these at these two instants of time, the displacement can be maximum or minimum. At those instants of time, the displacements can be maximum or minimum. So why can they be maximum or minimum? Because the slope of the graph at the maxima or the minima is always 0. So this value of time, which is 0 seconds, or the time which is 4 by 3 seconds, it either can be maximum or it can be minimum. So then how do we identify whether it is maxima or the minima? For that, we have to double differentiate this equation that we have. That is, for minima, for we are supposed to calculate the maximum, so we'll just stick to that. Also, for maximum, double derivative of x should be less than, or should be negative, we can say, which is less than 0. That is d square x divided by d t square should be less than 0. So if you go back here, if I differentiate the velocity, which is acceleration, which is equal to dv by dt, which is equal to d by dt of dx by dt, from which I get it as d by dt of 4t minus 3t square, where we'll have it as 4t, differentiation of 4t is 4, and differentiation of 3t square will be 6. So this is double derivative, which gives us the acceleration, right? So double differentiation of the displacement should be less than 0, that is, it should be negative. So in that case, we can find whether it is the negative or the positive. So that means we have it, we have the relation like this. What is it? 4 minus 60. That means this relation 4 minus 60 should be less than 0. So for t is equal to 0 seconds, we will check, and then we also will check it for t is equal to 4 by 3 seconds. So now if I substitute it as t is equal to 0 seconds, what happens with the d square x by dt square value, which will be equal to 4 minus 6 into 0, which actually is 4, which is greater than 0. And if you take the same value of d square x by dt square, which is actually equal to 4 minus 6t, which is 4 minus 6 into 4 by 3, which gives me 12 minus 24 divided by the 3, which is minus 12 by 3, which is equal to minus 4, which is less than 0. So that means, which, for what time interval will it have 0, or the maximum existing is at t is equal to 4 by 3 seconds, will have maxima, because it is negative, which is less than 0. So therefore the particle will have the maximum displacement at maximum displacement at t is equal to 4 by 3 seconds. This is when, at what instant will you have the maximum displacement is at t is equal to 4 by 3 seconds, is where we'll have the maximum displacement. And how much will that maximum displacement be equal to? That maximum displacement, to calculate, we have x is equal to, I think, 4t square, sorry, my mistake, it is equal to, x is what, 2t square, 2t square minus 2t cube. So if you now substitute the value of, so t is equal to 4 by 3 seconds, we'll have x as maximum, and x maximum will be equal to 2 into 4 by 3 whole square minus 4 by 3 whole cubed. And that maximum displacement will come out to be equal to 32 divided by 27 meters, and this is at t is equal to 4 by 3 seconds. See, this maxima or the minima you might have learned during basic math classes, because here for maxima, the slope of the graph goes on to negative values, it goes on decreasing though. So we take it to be less than 0. So the double derivative should be less than 0. That will be the case where we'll learn it in basic mathematics. Yes. So the value for which the displacement is maximum is that the value of maximum displacement is 32 by 27 meters. And at what instant of time will this displacement be maximum? It is 4 by 3 seconds. These things which I wrote here, which is the condition for the maximum minima, is the slope is to be 0, that is at the maximum or the minimum the slope is 0. And for whether to verify whether it is maxima or minima, we will just double differentiate, and if it is d square x by dt square is less than 0, then it will be maxima, or if d square x by dt square is greater than 0, then it will be minima. Please remember this condition as well. Hope you understood. Thank you very much.